So page 3, part 2b, page 3. You can mention your doubts in a chat, even it's in any order, it's fine. I will discuss in sequence. And page 3, part 2b. So page 3, part 2b. Use information use information given with the equation is a forward reaction exo or endo. So what we have to do here in this question, they said we have to cool down to get the product. So it means we have to decrease the energy to get the product. It means the reactants have high energy and the product is having low energy. So if the reactant is having a high energy and the product is having low energy, which kind of reaction is this? This is an exothermic reaction. So the idea is that if we have to cool or reduce the energy, means to get the product, it's exothermic. If the same question was there and we have to increase or supply the heat energy, like we have to supply the heat energy and here it is cool. So it means the forward reaction will be endo in that case. Like we have to supply energy to get the product. So product is having a high energy and the reactant is having low energy. So in that case, the forward reaction will be endo. But here the forward reaction is exo. The 2 marks in the question, 1 mark is for mentioning that the forward reaction is exo, and the second mark, because decrease in temperature shift the equilibrium towards right or favored the forward direction. That's the second mark. Then page number 4, question 3a, 2 and 3. Okay. Page number 4, question 3. Name the catalyst. You have to memorize a catalyst for a Haber process. We use iron as a catalyst. And what is the most important use of ammonia? Ammonia is used to make fertilizer. Yesterday we did like nitrogen, like fertilizers are used for the essential growth of a plant, and ammonia is mainly used to prepare the fertilizers. Then page 6, question 5, part 1. Give another example of a reversible reaction. So like this is one of the example. What is a very common example of a reversible reaction in which like anhydrous copper or hydrated copper sulfate, CuSO4, the hydrated copper sulfate, when you supply the heat energy, it turn into anhydrous copper sulfate plus 5 water molecule. So you can it's this is an open response question. Open response question means the question is not having a fixed answer. It's just any answer is acceptable, which is systematic, like in terms of terminologies are correct use. Any answer is acceptable here. So you can give an example of any reversible reaction. Yeah, water. Yeah, that's true, Rafe. You can write like water in a liquid state turn into gas, or water in a gaseous state turn to liquid. You don't have to write equation. You can just mention in your words. You can mention hydrated copper sulfate turn into anhydrous by supplying the heat energy. If water is added, it will reverse. Next is page number 11. Can it be production of ammonia from hydrogen? Yeah, that's also correct. You can mention the production of ammonia. That's right. Yeah, that's also correct. If you write the contact process, manufacture of sulfur dioxide by reacting with oxygen, the reaction is reversible. That's correct. As I mentioned, it's totally an open response question. So it won't make difference. There is no wrong answer until it's totally you did something else, like you write which is not a reversible substance. Then the next I was discussing, page 11, 8, page 11, this is 8. What happened to unreacted nitrogen and hydrogen? So what we do, if the reactants are unreacted, does not react, so what we do, we recycle, like we use them again. When nitrogen and hydrogen are mixed together, it form ammonia, but maybe a possibility is there that this nitrogen and hydrogen may not mix with each other. So if the reactant does not mix with each other, what we do, we recycle, like we reuse them again. You can also say we reuse or use them again. Even we can reuse for the same reaction. It's not like the other reaction. For like first time, the nitrogen and hydrogen does not mix with each other, or a small quantity of a nitrogen and hydrogen does not mix. So we can use them again for the same reaction itself. If you mention other reaction, that's fine. If for same reaction, you can also mention. Question 9, part B, sure. Look, in this one, as you can see, the three different equilibriums are shown. You can first solve this question here. When you check the number of the moles, the reactants 1 plus 1, there are 2 moles and 2 moles of a product. So means there is no effect of the pressure. Pressure cannot shift the equilibrium towards right or left. Whenever, remember one thing, whenever we increase the pressure, equilibrium will shift towards side where number of moles are less. And if we decrease the pressure, equilibrium will shift towards side where number of moles are more. So in all the reactions, we are increasing a pressure. As you can see, all the graph shows the increase in pressure. Like on x-axis, we have pressure, so we are increasing a pressure. So for first reaction, the percentage or of a product won't change because we have equal amount of the reactant and product. But when you check the second reaction, we have 1 and 3, so total 4 in the reactant side, and we have 2 in the product side. So if we increase the pressure, equilibrium always shift towards side where less moles. So in this case, it will shift towards right. So what will happen? The yield or the percent, yeah, it will shift towards the forward, or the percentage of the product or the percentage of the percentage yield will increase, like more product will get. And when you check reaction 3, this is 2, 2 and 1. So 3 moles and 2 moles. So it will shift as we increase the pressure, it will shift towards the left hand side. So what happened to the percentage of the product? It will decrease. So 3 reactions are shown, like they are effect on the percentage of a product here. It is increasing. And which reaction is this? So which reaction the percentage of the product is increasing? That was reaction 2. So here you will write reaction 2. Here the percentage of the product is increasing, and reason is that because there are few moles of product. So when we increase the pressure, the equilibrium will shift towards the side of less moles. That is the explanation. Then in second part, what happened to the percentage of the product? So percentage of the product, no change. Which reaction is it? That is reaction 1. And reason is that because it has same moles of reactant and product. So the pressure does not shift the equilibrium, or pressure does not affect the equilibrium. And the last one, as you can see, the percentage is decreasing. And which reaction is this? It means that is reaction 3. So the percentage is decreasing. and the reaction 3. And reason is that because there are, when you check the number of the moles, you will find as we increase the pressure, equilibrium always shift towards side of less moles. So we have few moles of the reactant, we have only 2 moles of reactant and 3 moles of a product. So the reason here that there are few moles of the reactant than product. So and answer, when we increase the pressure, it will always shift the equilibrium towards side of less moles. Not more moles on the reactant side, Rafi, it's a less moles on the reactant side. So because whenever we increase the pressure, equilibrium always shift towards side of less moles, not the more moles. This was page 11 and 12. This was 13. Then in the beginning, this was page 12 I discussed for the whole question 9. Then there is page 17, question 13, part 2. Page 17. Yeah, 17, question 13. What is the effect on a rate of using the temperature below 400? Rate of the reaction, because rate refers to speed of the reaction. So rate of the reaction will decrease. Why the rate of the reaction will decrease? Because when we decrease the temperature, the kinetic energy of the particle will also decrease. So as the kinetic energy decreases, there will be few particles or less kinetic energy or few collisions between the particles, or less effective collision. That's, yeah, less effective collision. As a result, the rate of the reaction will also decrease. So rate will decrease as the temperature decreases. Page 16, question 12, 1 and 2. And less particle will have the energy more than activation, or or a smaller proportion of the particle have energy more than activation. That's why the rate will also decrease. Explain why higher pressure is not used. Explain why high, look, what is the reason why we don't, like, what is the effect on the position of equilibrium using the higher pressure? Where the equilibrium, whenever we increase the pressure, equilibrium will shift towards side of less moles. So this one is 3 and this one is 2. So equilibrium will shift toward the right hand side. But why we did not use a high, it will make it expensive. Like, because increase using a high temperature, or increasing a high pressure, it increases the cost. So whenever an experiment is there and question is why we don't use a high pressure. And you can clearly see that it is about 98% we are getting a product. So it's like about 100%. So it's at, even at 2 atm, we are getting about 100% of the product. Why we should increase the high temperature? So why high? It will make it expensive. That is one thing. And the second thing, because already at 2 atm, 2 atmospheric pressure, we are getting 98%, which is approximately 100%. Like we are almost getting 100% of a product. So then what is the use of further increasing a pressure? Page number 16, 12, 1 and 2. This is the contact process. What is the formula for vanadium 5 oxide? So this Roman number is the valency of vanadium. Vanadium symbol is V and its charge is +5 because the Roman number represents the valency. Vanadium is not VH, vanadium is V. And oxygen is group 6, so it is -2. So whenever we want to write a formula, valencies we simplify. It's already simplified, so we cross multiply. V2O5 is the formula for vanadium pentoxide. Vanadium pentoxide is an effective catalyst at any temperature, from 400 to 450. Scientists are looking for an alternative catalyst which is efficient at 300. What will be the advantage of using a lower temperature? For this reaction, which is exothermic, whenever exothermic reaction and we lower the temperature, what will happen? We'll get a more or a greater yield. So what will be the advantage of using a low temperature? First thing, because when we use a low temperature or decrease the temperature, we'll get more product. Because low for exothermic reaction, whenever we decrease the temperature, the percentage yield or the percentage of the product will increase as the equilibrium has shifted towards the right hand side. Yeah, but it is, what would be the advantage of using a low temperature? It reduces the cost. That is like it one thing. And the second thing is it increases the yield and save energy. Like reduce cost, save energy, that is also a mark. But explanation, you have to explain that as you will get more product at a low temperature, so you don't have to increase the temperature. It make it less expensive, or it save the energy or reduce the cost. So anyone else having a doubt in this? Yeah, it's fine if you mention less expensive. Any other? If in case if I miss your question, just let me know. So I will discuss now. Any doubt? No doubt in this?